This is a video of the second assignment of Internet of Things. For this assignment, Meindert, and I, Klaas teamed up to build an application for object detection. We will discuss how object detection can be used, some problems it has to correctly identify an object, and the challenges we encountered ourselves while building the application.
Our motivation to work on this project is because we are teachers for high school students in the Netherlands teaching computing science, and one of the subjects in this area is about data processing. How you collect data, how you process it into usable information. It's a very theoretical subject, and we want to explore the options of using the environment of Edge Impulse if this is a handy tool to provide to our students to learn the process of data acquiring, data processing, and the processing into usable information.
Object detection can be useful in different fields. For example, autonomous vehicles can use it. It can be used in surveillance and security. It can be used for retail and e-commerce, for example, for inventory management. And it can be used in healthcare to detect diseases. And there are much more fields that it may be useful. The general idea of object detection is that you train the system by uploading lots of pictures of the object you want it to be able to detect. Eventually it will learn how the object looks like by comparing all the pictures and to see what do all these pictures have in common. In the real world, unfortunately, object detection faces problems that are depicted in the picture on this slide. For example, the chairs in the pictures all look different, or the giraffes in the picture, they have dots on their skin, but when it's dark, those dots are not visible. On the website of Edge Impulse, when you build your own object detection application, you can choose from different models. Some of these models are YOLO, FOMO, and MobileNet, and they behave similarly. They all can be used to detect, classify various objects. They work in real time. All those models, there's a trade-off between accuracy and efficiency. Efficiency, so it can work on hardware that is not very powerful. Of course, you also want it to be accurate, but the more accurate you want it to be, the more powerful your hardware also needs to be. All the models work in slightly different ways, so the results will vary. There are a lot of parameters to toy with. For example, how to deal with intersection over union. Intersection over union is an evaluation metric used to measure the accuracy of an object detector on a particular dataset. Predicted bounding box is drawn in red, while the ground truth bounding box is drawn in green. The green box is hand labeled, and that's why we call that the ground truth. And the red box is actually predicted by the computer. As you have seen in the previous slides, the green and the red box, they didn't perfectly match. We can calculate actually how well these two boxes match with intersection over union. It is a ratio, and you can calculate it by dividing the area of overlap by the area of union. If the two boxes have a perfect fit, then the IOU is 1, and if there is zero overlap, then the IOU is 0. My estimate was that in the previous slide, the IOU is somewhere between 70 and 90. A IOU of 1 is extremely unlikely. So because of this, we need to produce a IOU threshold, which we call alpha, that decides whether a detection is right or wrong. So suppose we choose alpha of 0.5, then the detection in the left is considered wrong because IOU is 0.4 something, which is beneath alpha, while the other two detections have a IOU above alpha and therefore are considered right. But this is all subjective. If you take alpha of 0.4, all detections are correct, even the one on the left, but with alpha of 0.8, just one detection is correct. When you want to train a model, you usually split your data into 3 different groups. The first group is the training data set, and that is actually the data that you use to train the model. The second group is the validation data set, and you use that to provide an unbiased evaluation of a model. You use that to toy with the different parameters. And the last group is the test dataset, and you will not use the test dataset to train the model. You will only use it to test how your model is actually doing. We decided to split all the pictures that we took in a ratio of 80% and 20%. So 80% for the training data and 20% for testing data.
I'm trying to develop a model for object detection, which can be deployed on a mobile phone. I started with one object, photos, with my phone, for which I took about 30 pictures. As you see, this is my object, this is coffee cup, as you see, and they are all labeled. You can see the label like coffee cup, all kind of positions. And finally, I want to use already developed model to train my own model. And doing this, I need first to have set of data. Data set is finally divided in 3 parts. Training set, it has a validation set, it has a test set. So train my model to recognize this as being a coffee cup. And then I'm testing my model. What's the accuracy I get out of this testing? I managed to have accuracy of this test with using 29 images of 91% accuracy. Then use it in deployment mode, my phone, and when my phone scans the object, this coffee cup seen as a coffee cup. Developing a new model, a higher level model. In this video, I want to explore how to get accuracy for multiple objects. And I want my phone to recognize these objects. And this impulse contains the parameters used in the object detection model. I use the 96 width, the size of the image. When I go to the image part, parameters of the image itself, not of the impulse, grayscale. Then the features I have, it recognizes the features like this. And I can run a test, but I can conclude already without running a test that this is not really that good. My box is recognized as being orange coffee cup. I had a score of 20%. So this image leads to an accuracy of 20%. I want to improve this. And how to improve this? I can start with my impulse, set a different width. Let's say I make it bigger. Change the parameters for my impulse. Back to my parameters first and set this to RGB. And this is the result. Is this better than before? I would say no. I can try to improve this model by uploading more images, make photos of separate objects. There's also some interesting data here. You see all the training cycles has a different kind of loss, validation loss. Here this is very huge. You see it's diminishing. No, we didn't have any better results with this other model. So the only option at this moment, after testing different models, is we should use more data to get more accuracy. Finally, I made images, photos of only 2 objects, meaning I have only 2 classes left, labeled these images as having 2 classes, a coffee cup and my mouse. And you see very nice in the Feature Explorer, you see it recognizing 2 different objects as being separate objects. So after testing it, I now have a 90% precision score. Deployment mode. There is the coffee cup. As you see, it's recognizing coffee cup. It has 91, 94 accuracy. It's very functioning. It is really doing all kinds of positions. I have also a mouse. It's also detecting my mouse. Something else is not detected as a mouse. And it is detected as being my mouse. And this is detected as being my cup. And the other cup is not detected as being my cup, and this is detected as being my cup. I'm very proud. Our conclusion: can working with Edge Impulse and giving an assignment about the data object detection help the students to understand a theoretical subject like data acquisition, data processing leading into information? The answer is yes, because the theme is covered in the sense that data acquisition is covered by gathering images by phone, or by gathering movement by the microcontroller unit like Arduino Sense. Data processing is covered by using different models and playing with the parameters in the models. And finally, information is processed through a model detecting information. Theory into practice. leading up to motivated students.